All right, let's get this started. If you guys are here for web app fingerprinting, you're in the right place. Got 20 minutes. I'm trying to condense down a much longer presentation, so I'm going to move pretty fast. So specifically, this is web app fingerprinting with static files. Talk a little bit about the existing fingerprinting approaches that are out there, some of the shortcomings in those, some of the things that we wanted to avoid, and how this technique gets us there. Talk about the static file approach itself. It's a pretty simple idea, so I'll move through it reasonably quickly, and if you follow it, then we'll go on to some of the results of that. And if we have time, hopefully, I'll do some demos. If not, I'll go ahead and be demoing this technique in Q&A right afterwards. So we're talking here about well-known web applications. These are not the individual ones that people are writing internally, little one-off web apps or custom web apps, any of that kind of stuff. We're talking about sort of the off-the-shelf stuff that you go and download, some open source CMS or blogging software or database admin software, any of those kind of well-known packaged web apps that you can download, and more importantly, that I can download and get a hold of and build fingerprinting files for. So, you know, forums, email, e-commerce, all of that kind of stuff. Lots of stuff that was traditionally larger back-end thick clients or desktop software, utilities, all those kind of things that have been traditionally on larger servers are now running as web apps. So, slide that everyone has to show a whole bunch of icons. You've probably seen some of these. You probably use most of these on a daily basis, or at least some of these. We support most of these in Blind Elephant right now. If there's other stuff that you want to get supported, this is an open source project. We'd love people to help us build new SIG files. So existing fingerprinting approaches come down to basically regular expressions. There's a number of tools out there that will help you reach out and identify what web applications are running on a remote server, but almost all of them come down to banner scraping, regexes, stuff like that. And it works pretty well, actually. Take a look at a couple of examples of different machines and say, all right, if I look for this particular meta generator tag or this comment or something like that, then we can be pretty sure it's that web app. That works all right. It does require human judgment to go make that initial call of what string are we going to look for, what are we going to grab, or look for which file should we pull down and grab the version out of it, any of that kind of stuff. I wanted to do away with that entirely. I want to say, okay, if I can just identify an app, pull down the source, and have a machine make that judgment. I'm just one guy trying to support a whole bunch of stuff internally, and said, okay, if I can take all human judgment out of the loop, this will be really good. Also, with these regex techniques, it's sort of known that people end up doing banner checking to figure out what's running. So more and more web apps are making those go away. They're saying, hey, I don't want to identify myself as proudly powered by WordPress. I don't want to say that I'm running version 2.7.1. So whether the web app itself is doing it, whether individual users are going manually through the source code and taking that out, and often people are developing plugins that will say, okay, just go ahead and strip out all that identifying information for me. So relying on just regexes is a useful technique, but we want something that's a little bit deeper than that, and also doesn't require that human judgment for, say, new versions that come out, the strings change, any of that kind of stuff. We really don't want to interact with the app at all. If we can get away without doing that, we're much better off. Some fingerprinters like this are down there. These aren't bad tools. They're good tools. They do the job. I wanted something to go a little bit beyond that. So have you guys heard the parable of the blind men and the elephant? Any hands up? You guys heard this? Nice. Reasonably well-read crowd. Cool. So I like it. For those of you who haven't heard it, it's a parable on the unknowability of truth. It's a bunch of blind men or men in a dark room all touching an elephant, and one touches the side of the elephant and says, it's a wall, and somebody else touches the leg of the elephant and says, it's a tree. Somebody pulls on the trunk and says, it's a branch, or it's a vine. So all of these guys are taking one aspect of what they're looking at and jumping to the first conclusion that's there. And the story really pissed me off, because if they just sort of enumerated all of the possibilities based on that little bit of evidence as to what it could be, they'd very quickly come to agreement as to what it was. So one guy says it could be a tree or it could be an elephant. Another guy says it could be a spear or it could be an elephant, and on and on. In the end, if you intersect all of those possibilities, then the extraneous ones drop out, and the only thing it can possibly be is an elephant. So that's exactly the technique that we're doing here. No more, no less. So if you can follow that, then this technique should not surprise you at all. So here's what we're doing. We're getting all of the released versions of a particular web app that we care about. Just I'm going to their archives or oldversions.com or SVN and just getting all the source code and dumping it into a series of directories with those versions. We're going to chew through that looking for specifically static files, .js, .css, any image files, text files, pretty much anything that's not active content. We throw away .php, .jsp, any of those kind of things that we'd actually have to interact with the application. We don't care about those. This is static files. We're looking for only those. We don't have to be particularly selective about which static files. If we don't recognize it, sure, we'll take it. It's probably a static file. So those are the things that if we look at all of those, we'll be able to gain information from each one, and combined, that information should give us a decent amount of information about what's actually present on the other end. So we chew through these, all of this source that we've gotten, and produce two tables. These are fingerprinting data files. One's a path table. We use it to say what paths. If we go fetch this particular path, what versions can we get information on based on whatever we happen to find at that path. Obviously, we haven't interacted with the server yet. It's sort of what could this path possibly tell me if it's present. Then we got a versions table, which is sort of the reverse. If we've got particular sets of paths, we've got it down to 1 or 2, and we want to narrow it down, then the versions table will help us identify paths that will do that. So here it is, sort of in brief. We've got WordPress, various versions, /*, everything under there we want. And we're going to put it into paths table and a versions table. It's a bit of an eye chart for people in the back. So here's what it breaks down to. Files, keyed by files, values are hashes to versions, versus keyed by versions, and values are files to hashes. I'm using MD5 hashes because it was quick and easy. We could use any other hashes. In the future, we're hoping to go to some more interesting approaches of sort of fuzzy hashing or nearest neighbor search type stuff. Right now, it's MD5. Talking about a lot of files. Remember I was saying I want to take the human judgment out of the loop. Here's why. We get this massive explosion of the number of versions, so many files times many versions, often, as you can see at the bottom there, times many plugins, times many versions of those plugins. So there's just this giant combinatoric explosion of things that we need to deal with. And to intelligently look through each of those to say, hey, here's a file that gives us lots of good information. I mean, if we said, hey, changelog, that's very obvious. A human could go look for the changelog and pick that out. But we want to surface lots of less obvious files that may have equally good data. So from the paths table, it's got lots of rich information about across all the different versions, the different files that are represented there, and what between which versions those files change. That's what's really key to us. We're going to run a fitness heuristic that says, hey, select out of all of these thousands of files that are present on the different versions of the web apps, select me paths that I can go fetch from the remote server that are very, very likely to exist in any version that I'm possible to encounter, and also have been changed many, many times across different releases. As I said, changelog is kind of the obvious one. It's going to always be there, and it's going to change a lot, but many things, many apps don't have something like that. It may not be that obviously named, or it may be taken out in the install process because it's kind of a liability. So we're looking for something that gives us that much information but may not be obvious. Here is for, what is this, Joomla. These are the files that surfaced when we were checking a Joomla machine. So htaccess.txt, actually pretty useful because as new functionality gets added, they want to protect it with an htaccess file. But it leaks a lot of good information for us, so that one pops up to the top. You can see it's present in 31 versions of the 33 versions of Joomla that we support currently. And it changes 14 times. So we get a lot of sort of entropy information about, we're able to narrow the pool of possibilities a lot based on that, and we just sort of work our way down the list with other files that have about that much information. So here's some of the candidate files for something like movable type. Use a lot of CSS files, JS files, that kind of stuff. And these are all selected by a fitness heuristic that we can tweak a little bit, but so far it's been working out all right. Media wiki, documentation, changelog comes up there, machine picked again, readme, and then some other random stuff. .sh files may or may not be readable. That's okay. There's good information there. Let's fetch them and see if they show up. So totally data-driven approach. That's what we're looking here. So here's the fingerprinting. We take those files that we selected, root htaccess, root language, the English language file, all that kind of stuff, and we just fetch them from the server. No surprise there. Get request. They come back. We hash the data that comes back and say, does this match the hash? Does this match any hash that we already know about? If it does, remember in the paths table, it's matching, it's doing hashes to versions. So it's going to imply some set of versions. Here we've got, the first file we got back said, based on the results, it could be version 201, 202, 304, RC4, some set of possibilities there. The next one, a different set of possibilities, different set of possibilities, different set of possibilities. And they can return a fairly large set of possibilities. We don't care about that. The only thing that we care about is, hello. There we go. The only thing that we care about is the intersection. If the intersection there is small enough for our purposes, whatever those purposes are, then the fingerprinter has done its job. So what this inner area represents is versions for which a file, some file, or more than one has provided concrete evidence for the existence of that version, but no file has said that version can't possibly be there based on what I found. Everybody jive with that? Cool. Got a couple of heads nodding. Awesome. If the version set that comes out at the end, if that intersection isn't small enough, then we can do a process called winnowing, again using all the same data that we've gotten. We go to the versions table this time and say, hey, I think it could be version 3.0, 3.01, 3.02. Give me some files, give me some paths that will help me confirm or rule those out. Versions table can pop out some paths for you. You can check as many of those as you want to narrow it down. And hopefully you should get some data based on those that will let you intersect farther down. Also, this data allows us to do app discovery, app guessing. If you know it's a blog, but you don't even know which blog it is, you can't fingerprint it yet, you want to know which one it is so that you can select the right data file. You can quickly skim out a few paths that are present in as many versions as possible. Screw the criteria about does it change. We want to know, what's a path that should be there in just about every single one. Grab that one out instead. Stuff like the image for the project. If in /image there's a Joomla logo that we can recognize exactly, yeah, probably good. Could be some other stuff going on. We check a few more things. So the same data allows you to do a variety of different things that all come in and are helpful for fingerprinting. So yeah, send those to the file. If one of them comes back, cool, we know it's there. It's some version. Then you can turn around and do a regular fingerprint operation. Supporting a new application, sort of alluded to this earlier, is dump every possible version you can find into a directory and take the file that says, take the build databases tool and say, go, chew through all these, spit me out 2 data files. You can reduce a couple of gigs of source down to 200K in the fingerprint files. So these are real nice. The fingerprint files that I've got currently are checked in the SVN here. If you want to get them, play with them, or use the data for some entirely other purpose, it's all there. So does it work? That's the question. We build a tool. It's only interesting if it actually works. And this one works pretty well. It was started out as an experiment. Can we do this? The guys over at Security, a web app security company, sort of posted a blog post on this a while ago saying, hey, here's an interesting idea. And so I kind of ran with that. This is the result. This tool is the result of that. So here's fingerprinting, my boss's website. So what we've got is loads up the database, says supporting 96 versions here. Starts fingerprinting. You can see these files start getting fetched. And based on the results of that file, we bring it back, we hash it. Does it match a hash that we know? If so, does that imply some set of versions? Cool. Here's that set of versions. Keep going down. It's currently set at static, fetch 15 files. We can do much more intelligent stuff to make this efficient, but I'm lazy and this is working so far. So if anybody really has a bug about efficiency, come talk to me. We can do all sorts of interesting stuff to narrow this down. More sets of files coming back. You'll notice that these version sets are actually pretty large. But that's okay. Remember, we only care about this intersection. any of these other sets can be as large as they want. As long as the intersection is small, we're totally cool. So end result comes out, all of those different pretty large version sets you saw condensed down to these 4 possible versions, which are really 2 versions, 4.2.2 or 4.2.3. And if I remember correctly, this is actually an old version, so I'm going to harass somebody about that. But so yeah, it'll pop out best guess. This tool is both sort of command line and also it's a library. So if you don't care about fingerprinting stuff on your own from the command line, you can go build this fingerprinting into your technology, whatever you want to do with it. It does plugins too. Again, we're trying to do all data-driven, trying to take human judgment out of the loop, so that lets us say, hey, if you can get a whole directory full of plugin releases, sure, we'll chew through those and happily support plugins for you. I've got it set up for Drupal and WordPress plugins right now. If there's any other app that we currently support that you want to add plugins to, we can do that. And if there's brand new apps that support plugins, we can do that too. So you can say, hey, just like guessing an app, you can guess plugins and spit out a list of possible plugins, and then go fingerprint those. So we got a cool toy. I went and got a dump of all the .com domain names that existed on a particular day in June, and ran this on a sample of those. So a little low on time. I'm going to buzz through this pretty quick. These graphs are version distributions that I found of what apps are running out there. So found a few thousand Drupal apps and a few thousand Drupal installations. You got the most recent versions, the release candidates, the alphas, the betas at the very top, and really old archaic versions down at the bottom. And you can kind of see that it trends. We got a few people running the really old stuff and kind of a nice bell curve within the last 3 to 8 releases. And that's pretty cool. Seems like people are staying reasonably up to date within 6 months or something like that. The question is that good enough? We know that all web apps out there have security problems and people do updates. So how do you guys think people are doing in terms of serious vulnerabilities? I've got a line on here that shows how up to date people are, or rather how many people fall below the line of if you're updated to here, you're safe from any serious vulnerabilities. Hands for 50% of these installs are affected. Less than 50%. Anybody think less than 50% of people are affected? More than 50%? Okay, we have some realists. More than 75%? About 70%. And this is just people who are running versions older than the latest published vulnerability. There could be configuration things going on that make them safe. There could be web app firewall rules. I'm just talking about specifically installed versions because we're looking at versions. That's the tool I have. How about Joomla? More than 50% affected? More than 75? More than 80? Okay, I'm leading the question. How about MediaWiki? You guys all use this internally. Everybody has a wiki on their intranet. More than 70%? Probably about 95% on that. You guys see these spikes here. Take note. These are hosting providers and package managers. So if you're relying on a hosting provider or a package manager to keep you up to date who's not backporting patches, some of them are, many are not, then you are probably quite a ways behind. Moodle, it's an education system. Movable type, I'm going to buzz through some of these. PHPBB, they yelled at me, so I'm not going to pick on them. Here's the weird one. PHPMyAdmin, all over the place. You'd think that if your blog isn't high severity, you would, you say, okay, I can update that, whatever. But no, PHPMyAdmin is really important. If that's your database management solution, it's critical to you, so you don't update it. That's backwards. But think about that. The really critical stuff, once they get it working, nobody wants to mess with it. So PHPMyAdmin is there, 85%. I'm going to skip through. Here's WordPress. Okay. My shout out to WordPress. They have a really, really good install and update process that's really simple, and people have found that it works, so they update. All the rest of this stuff have really good information about what security, what vulnerabilities are out there, what kind of exploits. WordPress has none of that. The one thing that they have is hey, it's very easy to update. Users can rely on it to do the right thing and to get updated. And that's the thing that is helping their users stay up to date. It's convenience, not fear or not understanding of security. The only thing that people are caring about, if you've seen the rest of these slides, is this convenience of staying updated. So anyway, there's WordPress at 4%. Does that surprise anybody? WordPress we think of it as vulnerable, but so far it looks like from some of their practices, they're actually doing a better job than people generally give them credit for. I had to pick on them a bit. So if we look at medium vulnerabilities, not criticals, it takes them up to 21.5, but that's still looking really good. So precision, buzz through these. If you're using this in the field, you should see about 1, 2, maybe 3 versions I can pin it down to, with a couple of weird outliers at 12 and 23. Speed, should see results come back in 3 to 6 seconds. 95% of runs get done in about 10 seconds. So you can use this as an interactive or reasonably scalable tool if you want. Lots of sources of error, all sorts of things that could go wrong with this process. But so far it works pretty well. So if you want to gripe to me about why I'm doing it totally wrong, come on over and we'll talk and you can help me. So this is an open source tool. I think we've released it as LGPL. Blindelephant.sourceforge.net. I've already been, 2 people have told me about bugs and stuff that I omitted. So if you go to that code and it doesn't work, hit me up on Twitter and I'll help you fix it and get it right. Love to see what people can do with this stuff. To do lots of help that we need, and I think I'm about out of time. Thank you, everyone.